Hey guys, welcome to Programming Knowledge. In the previous video, we were making our second project, which was a snake game, and we made quite a progress, right? So let's see what we have made. We have made this board, and then we have updated the board without causing any flickering, and that's a great improvement. And we have also animated this character which can eat the food, and we have also written the logic for the food to appear at different random locations, right? In this video, we'll complete this game by adding the body for the snake. Well, you know that the snake is growing while eating the food, but it's just growing in numbers, right? We're not showing it visually. So we'll be showing that. And also before that, let's just fix some logical errors which were made. Right? So let's see what are those errors. So let's just try if one of the error pops up. But I'm turning unlucky with just to save the time. I'm just ending this game here. And let's first talk about the most obvious logical error. So in the definition of food, what we have said is once a food is created, I want the random location on the board which will be the location where our food is placed, right? That's what we said when we are calling this generate food function inside the constructor, right? But what is happening here if you run this program again and again? So let's run this once again. So here you will be seeing that the first food is over here. And if I close that, run that again, you will be seeing that the second time also the food is over there. But the consequent foods are getting randomized. So if you see the second food is somewhere over there, and if I start this game again and try to eat that, you see that the second food has been generated at some random location, right? The first one was somewhere over there. So to fix this, well, you can go with it. It's not actually an error. It is actually not what we wanted, right? It's basically what I did not want. But if you wanted that the first food should be generated like that, you can go ahead with this and skip this portion. But since we wanted to generate the food at a random position right from the beginning, what we are doing wrong is here first we are generating the food object and then we are seeding the random function. Right? So if we were introduced to the random function and the seeding function back in the tic-tac-toe video, right? So if you remember, the seeding function is a kind of controller to the random number generator. Well, the random number generator will generate some random number. It will do some calculation and give you a number when the program is loaded onto the memory, right? So if you want a different random number, what you need to do is you need to close everything and then open it again. Well, we don't want to do that, right? We want random numbers right when we are in the memory. So what we do is we change the seed. So seed is like a starting point of the algorithm. And what we do is we seed it with some number every time we want to generate a new number. So what is the thing which is changing constantly? Well, time is changing constantly. So what we do is we just seed it with the time. So this one will take the time. It will take the time as an integer and then make the random number generator start from that particular time. That is why you get different numbers after seeding it. But what is happening here is we are calling the random function before seeding it, right? For the first time. From the next time onwards, once the food is eaten, the logic is over here, right? Which is after the seeding function. That is why you are getting randomized locations for the consequent foods, but not for the first food. So to fix that, it is very simple. What you can do is you can get rid of the constructor. Well, I don't know why I defined this constructor. Well, basically, when we define a constructor, what we actually see is we need the constructor to do something which the default constructor, which the compiler will construct for this class, can't do. Right? But what the default constructor does, it will basically create the memory required for this particular class, right? For loading this class onto the memory, you need some amount of memory which is calculated by the constructor. Well, we wanted the constructor to do something extra that is called this function on the creation, and it did not work out as we expected. That is why we can just get rid of the constructor and then call the function manually. Well, if you want to keep the working of the program just like before, then you can skip the step as I told you. It's just preference, right? I prefer that the would be generated at a random location right from the starting. So you can go there and after seeding the function, what we can do is we can now call the generate food method. So this is the one line which we wanted to skip by using the constructor, which was actually worthless, right? So creating a constructor was not good, and at least for this kind of a game where we want the first element to be randomized, so it basically get rid of the constructor, and that will solve the issue. Now, if you run this, you will be getting the foods at different locations. So one is being generated over here. Close that, open that again. Well, so the other one has been generated, but this is the problem actually which I wanted to show you in the beginning, right? Well, when I was eating the food, I actually knew that at some point this will happen. That is, you won't see any food on the food. That is a major logical issue with this program which we made in the previous video, and we will be fixing that right now. So here, if you see, there is no food on the board, but actually it has been generated. We'll see why that happened. Okay, so close that, and now we fix the most obvious issue. Now let's go on to the issue which we just saw, that the food is not getting generated. Well, what we're doing in the generate food method, well, here we are saying that we want some random number in the range of 1 to width minus 1. Why? We told that the first character is basically reserved for the first wall, and the last character is reserved for the last wall. So basically you want numbers from 1 to width minus 1, leaving those two characters. It sounds reasonable, right? But if you work on the math, it is going to tell you a totally different story. So let's see what the math is. Let me pull up my paint over here. And now let's first talk about one of these, so width or height. Both of them are going to go with the same logic, so we can talk about only one of them, right? So here, let's say I draw the height. So what is the height? Height was something like 25, right? So the whole thing is actually 25 characters, right? And what we are saying that the first character and the last character are reserved for the walls. So from a computer's perspective, what are these numbers going to be? The computer starts counting from zero, right? So 25 characters is basically 0 to 24 for a computer. And what we are saying is we are saying that this 0 and this 24 is not required in our range. So basically we want numbers from 1 to 23. We don't want 0, we don't want the last character which is 24. Right? So this range becomes 1 to 23. Well, to get a number in this range, what you can do is plug it into the formula. So, what is the formula for random number generation? It is if you want a number from, sorry, L, that is the lower limit, to U, which is the upper limit, and lower limit is included and upper limit is not included, right? So, you will be getting some numbers till U minus 1. So, if you want numbers in this range, that is L inclusive and U not inclusive, you won't get the U. Then the formula is you need to plug in rand mod. It was U minus L plus 1 plus L, right? So this is a formula. You can plug it into this formula. You can even see logically. Well, basically, both of them are going to give you the same result, and we'll just use the formula for simplicity purposes over here. What we can do is just plug it into this formula. So what it becomes, let me just write it as R. This is basically the random function R mod, and U is over here 24, right? Because we want 23 to be included, right? And in this formula, this particular U is not included in this random number generation. So we'll just increase this by one number, that is 24, and that will become 24 minus L plus 1, that is 1 plus 1. The lower limit is 1, which is included, that's why we don't have to do anything to it, and plus 1. So what this becomes is R mod 22 plus 1. And what is 22? It is basically 25 minus 3, right? So this is the number which we wanted to generate actually. But what we did is we basically went by our intuition and messed up the logic, right? So to correct this, what we need to do is using this particular formula, this becomes minus 3 and this will become plus 3, and the same will go with height also. Well, we talked about height, the same thing will go with the width also. So if you draw a similar kind of analogy, you will be seeing that the same logic will work for the width also. Right? So let me just clear that. And here it is minus 3 and this is plus 1. Now this will fix the disappearance of the food. And there is another major flaw in our looping, right? So where are we looping? We are looping over here, right? The board where we are displaying. There is a major flaw in that. And believe me, if you have been able to identify that particular error, you are going to be a great programmer, right? So let's see what the error is. It is basically lying within the inner loop. What we're doing? Well, for the outer loop, it is pretty straightforward. We are going from I equal to 0 to I equal to height, which is basically how the computer sees numbers from 0 to n minus 1. And for the width, we are doing something different, right? So what we're doing here, we are saying that we are going from 0 to width minus 2, and we had a reason that these two characters, which are basically the walls, are constant for all the rows. So instead of including them inside the loop, why not just exclude them and run the loop only for the width minus 2 number of characters? So that's what we did, and that sounded reasonable. But here is the problem. What happens is, let's say my generated x-axis, which is basically the width, is going to be 28, right? Sorry, what is the maximum range? It is 50, right? And what you can do, if this is 50, the maximum number you can generate leaving 0 and 49 is 48, right? So this is the maximum number you can generate, and let's say that that is our x coordinate, that is the value of our width. Now what happens here? Well, if you see here, j is running from 0 2 width minus 2. What is width minus 2? It is basically 48, and it's not reaching 48. It's just going till 48, which means going till 47 only, right? Now if you see this, you don't have a way to actually display this coordinate in this loop at all, because it is out of the bounds of this particular loop. This loop will run only till 47, and you are asking it to show something which is on the 48th coordinate, which is not possible by this loop, right? So how do I fix this? Well, we can draw an analogy over here. So if you draw the coordinates with the j's perspective and the w's perspective, w is basically the original width of our board. So see this, when w is 0, j is not at all defined. Why is that? Well, let me just clear this thing so that we can see it clearly. But this is the leftmost corner of our board, and this is 25, right? 25 characters or 25 pixels. And here, what we are doing is we are saying this is our character, the width character, and we are saying that the inner loop should run from 0 to 47, and we are including another character, and the total makes it 50, right? So 0 to 47 is 48 characters plus 1 50, and this is the other one. Now what is happening is, let's say my coordinate is 0, right? When the x coordinate is 0, it basically means this particular position where the wall is there, right? But what is happening here? Our 0 is starting from one step to the right because of this particular looping and this particular character before the loop. So what is happening? Our loop, which is starting one step towards the right, and that is why we are missing out our coordinate. So what happens is, if if w, which is our original x-axis, is 0, j is not at all defined. It is not there at all. And when does j equal to 0 start? When width equal to 1, and so on. This will continue. When width equal to 48, j equal to 47, as we just saw, and width is 49, it is not present at all. Right? So this is the reason why we were not getting anything on the board. Not This is not the complete reason. The actual reason was because we were messing up the formula, the random number generation. But here, this is another one of the major reasons why we won't be getting even after fixing the random number generation. That is because if you create any food at the extreme positions, that won't be visible to you at all. Right? So to fix this, what we can do is, while comparing the coordinates, we need to add 1 to this, right? So if 0 plus 1, well, we don't care about the 0 or the 49th coordinate, right? We don't want these two things, because we're not going to generate food at those two things. They are walls, they are reserved for walls. So in this range, 1 to 48, what you need to do, you need to compare only these things, right? You need to compare only these things, and to compare that, what we can do is we can add 1 to the j before comparing it with the x coordinate. So to fix this, what we're going to do here is, well, we need the canvas. Let me just clear this. And here, in place of J, it's going to be J plus 1. And that should hopefully fix all the logical errors which are made. So save that, run that again, and here we have our first food. If you eat that, the second food is getting generated, and hopefully it should not stop generating. It should be generating till we play this game, and it should stay within the range of board, and it should be visible to the player, right? So well, if you say this is visible, and trust me, it's going to work, and there are no kind of mistakes in this program, and this is completely fixed now. Well, we'll fix one more thing, that is, if I go to this particular wall, I will crash before actually crashing. So if you see this, I have not yet crashed the wall, but it's in that I have crashed this wall. That means I need to go inside the wall. So to fix that, I will, it's the coordinate issue and also a placement of moves. So let's first fix the coordinate issue. If we go there, snake dot collided will have already fixed it. Basically, what we did was we had put something like this, right? Position dot x is less than 1 and position dot x is greater than width minus 1. So going by the same logic, width minus 1 is going to be 49 because width is 50. So width minus 1 is going to be 49. So what you want something greater than 48, not 49. So it's going to be width minus 2. And that should fix the issue. And for the other wall, which I just showed you there, for the rightmost wall, what is happening is we are first drawing the board. We are actually changing the direction of the snake. We are moving the snake, and then we are checking whether it collides or not. Basically, this movement is not shown at all. Right? This movement is not shown to the user. This movement should actually happen after this collision checks are done. So what you can do is you can just move this to the end, or you can even move it to the start. Doesn't matter. Basically, the board should be updated after the snake moves, not before the snake moves. That is what is happening over here. The board is actually getting updated before the snake moves. So that is why you're not seeing whether the snake has been collided or not. So you can just move this thing to the end or move this thing to the start. Basically, they both mean the same thing, right? So for the next loop, the starting point is going to be the end of this one. So they mean the same thing. So just move this to the end or start, whatever you wish. Right? Now this should fix that issue that you're not seeing the snake colliding, and now you should see that the snake actually collides with the wall before ending this game, right? So it went inside the wall and the game ended. And now everything is pretty much fixed. And now let's proceed to making the snake game a real snake game. What is that? We need to include the snake's body. We are just growing the snake, which is basically just increasing the length, right? So here you can see it's just increasing the length. So how can we store the snake's body? Well, what is a body? It's just a collection of body parts, and that collection must have triggered something inside you. Well, we are going to use something like an array, which is a collection, a vector, which is also a collection, which was seen in the pointers video, and the other thing is list, right? So these are three options available to us as of now, and we'll use one of this. Now let's analyze what we need to use over here. Right? So array needs to have a fixed size while defining. And how do we know the fixed size of the snake? Well, if a player like me is going to play, he's probably going to get defeated in let's say 5 or 10 points at all, right? Because I'm a very bad player, and maybe a pro player comes in and he can make a score as big as 1,000 or 10,000, right? Well, you cannot restrict the players or you cannot estimate the player's capacity by just keeping a fixed number. What if the player is better than what you thought he should be, right? So here, what you can do is, well, in this particular board, you can actually fix it to some big number. So let's say the maximum number of characters possible is what? Well, here the width is let's see that width is 50 and height is 25, right? So the maximum number of characters possible is this thing, 50 times 25, out of which you're using the borders. So that is the only number of characters. So if you make the snake as big as that, after that there is no possibility of winning because the snake has to collide, right? Because the maximum free space has been used up. So basically it has to collide with one of the walls and you end the game. Well, that is a very cheap way. You don't have to do that. And while defining with graphics, we generally what we do is we'll take off such limitations, right? So that is why you have such teleportable walls and all to take care of this issue. But for this particular game, we won't be talking about the teleportable walls. But in the end, I'll show you how to create teleportable walls if you want to. And here, basically, the array is a very bad option because you are restricting the player's capacity. And if you talk about vectors, well, it is dynamic, but again, it is going to take up some extra space while defining. So if you remember how vector works, it first defines some amount of space, and once it gets filled up, it will define a bigger space, and then copy all the elements to this and get rid of this particular space. So this one could be used, this could work, but again, there is some extra space which is getting wasted. So basically, the best option here is going to be list. So if you remember from our video on the pointers where we first discussed when to use vectors versus when to use list, you saw that list can be used whenever you have a data structure where you won't be accessing the middle elements more frequently. You're just going to access the first and last element. That is the case here also, right? You're not going to access the middle elements, which is basically these body parts. You're not going to access it. We are just only concerned about the head, which is on the front of the data structure, and then tail, right? So we'll talk about how to actually manage the head and tail in a short while. But for now, the head is at the beginning and the tail is at the end, and we are only bothered about these two things. We're not bothered about the middle elements. Well, we are basically when we want to check the collision, we need to consider the middle elements also, but we can just do it in a progressive loop, right? So basically, it doesn't make any difference, and we can't actually harvest the advantage of being able to pick some random element from in between. Well, in a vector, we can do that very simply because it is a continuous collection. But in a list, if you remember, it was something like this, right? You have pointer to something, and then you have another pointer which points to this, and so on. Right? So if you want to pick this thing, you need to cover all this way. But in a vector or in an array, you can just pick that up using the index. It is basically the starting position plus the number of steps you need to travel. So in this case, a list would be the best thing to implement, but to keep this tutorial simple, I'm using vectors for this particular demonstration. So I would totally encourage you to go with list, not with vectors, as we are going to see in this video. I'm just showing with vectors because it's easier to relate than this, right? But once you're comfortable by implementing this particular project in a vector, please go on to try it with a list. List is the most preferred option for such games where you don't have to control the capacity of the user. Right? Vector is not going to control, but basically the extra space is an issue. Right? We don't want that. So please try it with the list, and let's now move on to the logic of creating the body. Right? We need to just clear that. And how do we define the body? Well, it's really simple. So let's say I have two body parts, well, basically a tail and the head. I have this head over here, and the snake has to move to the right. So what can I do? Well, what if I just remove this tail and then put another head over here and make this as a tail? So for tail, let's just say this X mark over here that denotes a tail. Now, if you see that the snake has put one step to the right, right? And if I do that again, so I take out this tail, I include the head, and I make this head as the tail. Now the snake is moved again, and let's say we are eating the food at some location. So let's start with another snake. So this is the snake we have, and the food it is going to eat this particular food. So it has eaten. In the next iteration, what I will do is I won't take off this tail. Right? I will keep this tail, and this is what happens. Right? So I add the head. I won't remove the tail, but I'll make this head as a tail. Right? So now you have two tails and one head, and that basically looks like the snake has grown, right? From two body parts, it has grown to three body parts, and that's what we want, right? So this is the logic we are going to implement, and we are going to do that in vectors. Again, list is the most preferred option. Please try it with a list, not with a vector. After you're comfortable, basically. Right? So let's just go to our snake.h and quickly create a body definition. So we need vector obviously. So hash include vector. If you're going to do it with a list, you know, right? Hash include list. And well, since vector is a standard scope element, you need to specify the scope. So using namespace std like we did in the main function. And here you can just say vector body, sorry, vector, and what is the data type? It's going to be coordinates, right? Basically, so chord and then body, and this defines the body of the vector. Now there are few changes we need to make. What is that? First of all, we need to include the head to the body once we create a new snake. So in this snake chord constructor, what we're going to do, we're just going to say body dot pushback, which is basically pushing back the elements inside a vector. And what we need to push back, we need to push back the position, which is basically the position of the head of the snake, right? We can just body dot push back that particular position. And while moving the snake, following that logic which we just discussed, what we're going to do is first we are pushing the head of the snake to the end of the list or end of the vector. So how we do that? Body dot push back the new position which has been updated after all these things, so new position. And now what we'll do is if the body size is greater than the length of the snake. What is the length of the snake? That is the thing we are growing when the snake is actually eating a food, right? So that is the thing we are manipulating over here. So this length integer, if the body is size, which is basically the number of elements in the vector, is greater than the length, then what you do, you just take out the element from the body. So how do you do that? You just say body dot, and if you're actually confused with what function you need to use, the best thing I would suggest is not just memorize the function, but just use the resources. So you can just go to your web and then search something like CTP vector documentation, and you'll get a lot of resources. And c++.com is the best one among them. Well, I feel that this is the best one where you can find short descriptions of all the functions, right? And here you should be saying some function like pop back. What does it say? It says that removes the last element in the vector, effectively reducing the container size by one. But we actually don't want this. Right? Well, why is that? If you see, well, technically the tail should be at the end of the body, but if you look at the structure, what we're doing is we are actually pushing back the head one step to the right, right? So this is what pushback does. So basically our head is over here and our tail is over here. And what we need to do, we need to remove the first element. So how can we remove that? You can just check out the functions over here, but to save the time, I'm just going to show you the function which is basically clear or arrays, right? So you will find this one. This is basically going to remove from the vector either a single element or a range of elements. So here we just need to remove a single element. And the position is not an integer, it's a pointer. So here you can see it says the definitions iterator position and iterator first and iterator last. Well, you can go with any of this. The only difference is that it has a constrainer, but you don't have to know at this stage, right? You can, well, you can just go and search what these two things are. Basically, they be the same thing. And how to use that? You can see an example over here. It says dot erase my vector dot begin plus 5. So plus 5 is basically going 5 steps away from the first element, which is basically the sixth element. And that's how you use this arrays function. He has also shown an example to delete a range. Well, we're not quite interested in erasing a range. We just want to erase a single element, which is going to be our first element because our first element is the tail. And what we can do, we can just say my vector dot begin plus 0, that is stay at the first element, or you can just omit the 0 and just say my vector dot begin. That is going to erase the first element. So let's implement that. What we're going to say, we're going to say body dot erase, and what we're going to erase, we're going to erase the first element, which we can get by body dot begin. This is the pointer for the first position, right? So this will basically erase the first element from our list. And well, before proceeding, let's first see whether this is working or not. Right? And we need to create another function. Well, let us keep this function for now and then create another function just in case something goes wrong. So vector, and it is going to be coordinate, right? You need a coordinate vector to be written. Well, basically we are going to return the snake's body. So snake, and then let's say get body, and inside this we can say return body. And in the snake.h, you can just create that function definition, which is basically vector code, sorry, what is that? Get body. Right? So now we have updated the snake's definition. Now we'll just update the board. And what we need, we first need a vector to capture the snake's body. So vector quad, let's say snake body equal to snake dot get body. And inside this, what we're going to do, well, just remove this else and we'll place this afterwards. What we're going to do is, inside the else, we are first going to loop through the snake's body and see whether any coordinate matches or not. So what we can do is, we can just say this body part, which will stay false in the beginning, right? We'll change that in the loop. Now what we can say is for int, well, I just used it, so k equal to 0, k is less than our body, which is snake body dot size, and k plus plus. What we're going to do here is, inside this loop, we'll say if ith coordinate, which is basically going to control the y coordinate, is equal to the snake body of the kth index dot x, sorry, dot y, and j plus 1, well, remember that's the logic we were messing up, equal to snake body dot, sorry, snake body of that particular index dot x. If these things match up, then what we need to do, you need to display a body part. So let's just go with this small o for now. This is our body part, and if body part becomes true, equal to true. And what else? Well, we don't want to run this thing, right? Because at an instant, a particular body part can stay only at a particular location. So if that location is occupied, it is pretty obvious that any other body part won't occupy that location. So you can safely break out of this loop. You can end this loop. And in the end, what you can say is, if it is not body part, if not body part, then obviously it is going to be just an empty space denoting the empty area. Right? And here another thing is, here we are going to body dot size, but remember body includes the head, right? So what we can do is, we can just say body dot size minus 1, which will basically leave out the last element. And now this should work, and let's try to implement this. So F9, and here you can see that the snake has grown. So the other foot is over here. So well, I ate that, and the third foot is over here. Well, you can see that the snake is growing, right? So here you have four body parts of the snake, and now if I eat that, here now you have five, right? So now we have a working snake game, right? So now you have a working snake game, and this works pretty fine, right? So now the you can see that the animation also works pretty fine. The body parts seem to follow the head and so on, right? So this concludes our game. Well, I promise you that we'll be seeing how to create a teleportable wall. And before that, if you want to show a score, that is also pretty simple. What you do is, you just say here int score. Well, just keep it global so that you can use it on the board function also. So here you can just say int score, which is going to be 0 in the beginning. And well, you can just set this to 0. In case you want to say play again, something like that, what you can do is, instead of main, you can just say game, and this is going to be void game. Well, I'm not going to do that. You can do that, right? So if I want to play again, you can ask a question, do you want to play again or not, something like that. And if I press yes, then you can call this function again, and then you can set this thing as 0. So core equal to 0 before the beginning of the new game. And here what you can do is, you can just say score plus plus, very simple. And if you want to give 10 points or something like that, you can just do that score equal to score plus 10, or any shorthands if you know score plus equal to 10 or something like that. You can do that over here. And here, before starting to print out the board, what we can do is, we can just say see out our score. So score is our score, current score, and just add a couple of new lines so that it looks neat. And that should take care. Well, I have one returning function over here, that is this foot, oh, sorry, the snake pause, which is actually getting the position of the head, and we are also getting the position of the body, right? And we did not define the collision of the snake, right? So we'll do that, those things. First of all, let's just see whether this thing works or not. So now you have this particular snake, and I ate that, the score is 10. Now I ate that, score is 20. I ate that, score is 30, and so on. So it's working pretty fine, right? So you can close that. And to take care of the collision, well, you might have figured it out by now what we need to do. Well, what you need to do here is you need to say else, and you need to check whether it collided or not. How do you check that? Well, you don't need a else at all. You can directly check it inside a loop and then return it. So what you can do is for int I equal to 0, I is less than the body dot size. Well, it's inside the snake, so I don't have to call that. I can just say length minus 1 because I don't want the head, and it's going to be I plus plus. Right? And what we need to check, if our snake's head is basically pos, right? So if pos dot x is equal to any of the snake body, well, it is not snake body, it's just body of I dot x, and the y coordinate is also same. Pos dot y is equal to bodies I dot y. If these two things match up, just say return true. Yes, you collided. If these two things don't satisfy in the end, just say return false. So this should take care of the collision. So let's just try that out. So F9 to build and compile this, and here you have this snake and the foot. And let's first go for our first foot. We have grown, and the score has also increased. And the second foot, but it's going to take a while if I go like that. It's just going one body part at a time. But what I can do is I just right away collide. Well, how can I collide? Well, I'm moving left now, right? So if I just press right, I'm just going to collide with my neck. So basically, I collided, and now you can see that the process has stopped. Basically, our collision algorithm is working. So that basically ends this game. And if you want to make a teleportable wall, it's really simple. What you need to do is, I am sure many of you must have figured it out right now. Well, you just need to play with the coordinates. So if you see in the snake move snake, what you do is, if you want to change the location of the snake, you will just say here, if this particular thing, if position dot x is greater than the width minus 2, then what you do, you just say position dot x equal to 0. So simple. And again, what you do, if you say if position dot y, or sorry, position dot x is less than 1, then what you do, you just say position dot x equal to the width minus 3. Sorry about that. For random function, we need to use width minus 3 because for generating the random numbers in that range, so it's basically width minus 2. And this will make the side walls teleportable. So if you just save that, and now if you run this, you should be going through the side wall and coming from the other one. And now, if I go to my side wall, I should be appearing from the other wall. So you can see that it has been kind of teleportation. Now, if I eat that, our tail will also follow our steps, right? So if you go from there, you appear from there, right? So it works both ways. Right? So that is how you make teleportable walls. And once you get to know about file handling, basically how to write files, what you can do is you can even have a high score option. So you can write down a particular high score on the file. So let's say I open this game right now, and I scored about 10 points and you scored about 1000 points. So that's pretty reasonable. I'm not a very good player, but yeah, so you score about 1000 points, and that is a high score, right? So here, if you run this program again, that high score gets lost. So instead of just writing it on the memory for that particular kind of run, what you can do is you can have a file where you can write down all your high scores, and then whenever you load this game, you load it along with the file. So inside that file, you have all the high score lists, and if you want, you can just have names also. So some games provide that, right? So you have the name and then the high score. Sometimes that you can design everything, and we'll come back to this by discussing files, right? So because traditionally what we do is we just write files about students and all this things. But we'll come back here and we'll try to work on this game more and try to create a file. And again, this is the total working game. And if you want to implement this, and if you're comfortable with implementing this with this kind of a vector, well, I made some redundant functions like this is completely sorry. This one is completely unnecessary because I'm getting the head along with the body. So you can take care of that. And again, I will advise you not to use a vector, use a list. And here, if you want to include another teleportable wall, there is this one. You can do that again with a similar kind of logic for y-axis, right? So you make basically all four of the walls teleportable. So when I had actually implemented this game in Python, and if you use a graphics library, you will be getting results like that. So if we go to our Python one. So here I have my game. Well, it is basically written in two files. One has the classes and one has the script, and it has various images. So what I have is the snake in parts. So here you can see body horizontal, tail up, tail down. So whenever that snake is going in that particular direction, you show that image. And now, well, you can run this thing right over here. You can see this game. This is what you can make with a graphics library. Well, this is pretty fast, but this is what you can make with a graphics library, and you can see how smooth it is. And it doesn't have any kind of issues like moving down faster in the vertical direction, moving slower in the horizontal direction. It has kind of same speed because you can control it, right? You can basically control the number of pixels and all. And if you see, it is teleportable on both sides. If I go from the bottom, I end up from coming from the top, and if I go from the sides, I end up coming from there. So this is how you can implement your games, and this is basically the same logic which I've implemented, except that I have some additional functions handling the graphics of this game, right? Nothing more than that. It is basically the same exact logic which we have talked about in this console, but when you use a graphics library, you get results like that. So once you're comfortable with programming this particular game on the console, I would advise you to look up some graphics library which is available in C++. There are many, so see what you're comfortable with and try to implement such games on graphics. Even the tic-tac-toe game can be implemented on the graphics library, and that really looks good instead of the console. Right? So, well, basically, what we are learning here is how to think, and console is the best way or the best platform to actually put down our ideas in a very fast way. Well, if I want to do the same thing in a graphics library, it will take a really long time. I need to initialize the graphics library. I need to do a lot of things before getting all these things, right? So if you're coming up with an idea, I would rather recommend you not to go to a graphics library, but first think and then put up a dirty kind of working prototype on your console, and then you can beautify it on the graphics library. So that's it for this particular video. Hope you enjoyed this, and I encourage you to build up your own game by changing the laws and then making it faster on the X and slower on the Y or something like that. I did not do that. I just went with a very simple approach, but I'm sure you can do that. And in the next video, we'll start with inheritance. Till then, happy coding.